Hi everyone, welcome to sprint number 5 of the Chord sprints, or the Chord in general. So we're going to start today a little late, sorry. My apologies, I was running late. I got stuck on the highway. Anyway, whatever. So let's move on to just an overview slide for this sprint. Can everybody see my slides? Yes? Yes? Okay, good. Anyway, so we had a 3-week sprint from the 5th of January to the 22nd. We accept 162 story points. We only added 5 story points mid-sprint, which is either wrong or very encouraging. But on the other hand, we only completed 56 story points, which is kind of miserable. But the silver lining is that there were 56 in progress. That's not, I don't know. It's either people aren't updating their stories correctly or we're really not doing anything. So 57 story points were not started at all. The remaining story points were in progress. Okay? Any questions? No? And so with that, I'm going to move on to the OLT and multicast stuff. So the OLT pipeline has been integrated into ONOS, so we have Q&Q integration, default EA poll, and IGMP flow rules, which is all good and nice. And actually that ties into other vendors are proposing their hardware. And so we've integrated Fujitsu, there's a couple more vendors coming along. And they all use the same pipeline so far, which makes our life easier, which is good. We've integrated into Chord by adding listeners to obtain notifications about access events, and these access events are a subscriber joining, going away, and a access device coming online and an access device going away.
How are those notifications sent to Chord? Are those in-process notifications or extra-process notifications?
From the OLT's perspective, they're sent in process, and then Chord has a notifier that then pushes it to Solometer. However, it's I don't know how. I'm not entirely sure. It does that. The integration. We've integrated into the fabric so we can get traffic from a subscriber through the OLT into the fabric to the right VSG node, which is pretty cool. It's not exactly a first ping, it's more like a first foray into the fabric.
First ding.
First ding, yeah, first ding. But it's good, that means that we have traffic flowing. So we probably should start building this stuff together, putting all this stuff together. So the multicast applications are all ready. They just need to be tested. I didn't have time to start testing the applications, but I will.
That includes PIM? So it's just IGMP?
It's just IGMP.
Who's doing the PIM? Oh, you are?
Yeah, because it's part of the. It's basically, there's a PIM state. Well, so there's two parts. There's the PIM application written by DirecTV that we hope to be able to reuse.
Yes.
Most of it.
Yes.
And then there's just like handling the PIM state machine, right, which is actually kind of a small little state machine to send up messages. And then there's an integration between the IGMP multicast application and the PIM application to when somebody asks for a group that isn't already in the system, to PIM for that group.
Yeah.
That's it.
So the DirecTV stuff didn't include the PIM state machine?
It does.
So
it does.
It does, yeah. So DirecTV stuff can form like an adjacency or neighbor relationship, as you call it, with a peer. But it only at the moment receives joins because their protocol is different. They're kind of the receiver of joins, right? And so we want to send joins upstream.
Yeah.
So that's the bit we have to do.
Okay. And also, I should probably say that I started testing with the real, or the actual residential gateway or CPE that we'll be using in the field trial. So it doesn't work out. But yeah, anyway, so that's that. So that's OLT and multicast. Are there any questions? No? Okay. So let's go to Core VTM.
I've done multiple small tasks this sprint. For service compression pipeline, I implemented adding or removing VMs to an existing service with a dependency, and added access rules between physical and virtual network. And I think I finished the whole complicated pipeline.
Cool.
And
When you say added access rules between physical and virtual network, what does that actually mean?
I added physical port to the integration bridge.
I get it. Yeah.
And I added ARP proxy for service IP, which is identical to gateway or virtual network. So we don't need to actually create a gateway interface using Neutron X3 agent. Actually, we don't need any Neutron agent anymore.
Yeah, wonderful. No.
And I implemented a small host provider which injects or ejects a host when a VM is detected or vanished, which if the port is VM port and if Core VTN successfully grab the host information from OpenStack. And added physical port add step to node bootstrap process, and the network config has been updated again, and I have a plan to make a wiki page to describe how to set up network config or Core VTN next sprint.
A lot of work.
And what's in the next items that are remaining?
I think I have to grab some service dependency information from XOS. To do so, I think I have to deploy XOS in my environment. That's the one big thing, and the rest of the things are small ones.
Okay, so I mean that means we're basically ready for that's next sprint. Let's move on. Thank you. This is really great. Fabric.
Right. So the big story here was that we were able to integrate with the OLT with a feature that we call VLAN cross connects. That turned out to be trickier than we had thought initially. But Charles worked through all the oddities, and we were successfully able to integrate with the OLT. Also, Flavio implemented default routes. We found a new bug in Broadcom or TPA, but we were able to work around it and implemented the default routes, which will let us integrate with vRouter once that comes out. In progress, Flavio started test on automated tests for the fabric because the code is pretty complicated now, and we do need regression testing for this. In the meantime, Charles is working on cleaning up some of the code base, some of the workarounds that he did to make the fabric work just before the break. For regular bridging and routing, we had it working, but we had to do a lot of workarounds. So Charles is working through getting all those workarounds into the main master code base. We're debugging a few issues along the way. Meanwhile, I'm working on vRouter, specifically on OFTPA with Jono. So one of the next things that we'll do is once we have vRouter working completely in a standalone box, we will move over to having that working on the fabric. And multicast is the other big issue that Charles and I will focus on in the next sprint.
So, have you tested the fabric on multi-instance Sonos?
We have, and those are some of the debugging issues that we are encountering. It doesn't work completely yet. Back in the day, I had it working completely on and reliably on software switches, emulating the hardware switches. So this is the first time we're trying it on multi-instance on hardware, and it doesn't work completely. So there's always little issues moving from software switches to hardware switches.
Sure.
Working through that.
Okay, multicast. Will you be able to do vRouter and multicast in parallel?
That would be the hope in the next sprint, because if I add the multicast support needed in the driver, then Charles can implement the multicast application for the fabric, while I then focus on vRouter with Jono for the fabric. So we'll see. We'll make progress on both things in the next sprint. Will they both be ready by the next sprint? I would hope so, but I don't know.
I'm just saying because it's harder to test when you don't have live multicast streams coming at you.
Oh, yeah, I agree.
But whatever. I mean, it's something we can figure out.
Yeah, I mean, I would say getting vRouter going would be
It's higher priority.
because then we truly have end-to-end.
Yes.
And
the multicast application that you're thinking of right now is not entirely necessary for phase 1.
I'm sorry, what?
We need to be able to forward through the fabric, right?
Yes.
A multicast stream, right?
Yes.
We can forward it point to point for now.
Yeah. No, that's what we do.
Yeah. But we don't need.
There is one place that we replicate, but that's really at the destination leaf.
Yes, and even that we could get away without replicating
Because it's only one OLT.
because it's only one OLT and 10 subscribers.
Right. I mean, I don't disagree with you. Nevertheless, it is still work to get that point-to-point stream.
Absolutely. I'm not saying that.
Because it's using multicast IP and MAC addresses that we have to do special things in the fabric to get that across.
Yes,
right?
and which we have to keep in mind that. Yes. Anyway, let's move on. Cool. vRouter?
Yeah, so we made a lot of good progress with the vRouter this sprint. We now have an application on Onos that's pretty much functional for unicast routing. So that involved implementing the BGP and OSPF traffic control plane redirect. Me and Sarah were working on that. And then we also finished off the FPN component, which is the thing that listens for routes from Quagga for route updates, adds and deletes, and then pushes them down to the data plane. And I also did initial testing of static routes, which seems to work coming from Quagga. And then on the hardware testing, I'm currently working on testing with NoviFlow and getting that integrated into our setup in the OnLab pod here so that we can kind of test the integration with the fabric. And Sora was working in parallel on OFDPA, we just talked about. Do you want to say anything more about that?
No, it seems like it's working.
Are you going to put the NoviFlow switch in the code?
Right now, just initially, we can. I mean, because really that involves setting up the external router to pair with stuff. So we can replace the NoviFlow with OFDPA and then eventually, hopefully, get rid of it completely. But all that other infrastructure around it still needs to be there for us to get anything working. And then the Tech Mahindra team is working on the protocol interoperability with the AT&T's test setup, and they have got OSPF and BGP sessions working with the AT&T's router. No issues encountered so far, so they'll be working on some more testing next sprint.
All right, CoreXOS guys.
So we had some good progress with getting VTN working on Cloud Lab with XOS. So we built a VTN configuration for development on Cloud Lab, and the setup is pretty automated. And Scott was able to get the VTN ONOS app installed in a container and was able to demonstrate connectivity within the slice and limited connectivity between services. So that's a good step forward. We also did some work on XOS itself. So there was a code cleanup to try to make things simpler for accepting contributions from the community. And there's a lot of interest from people trying to participate in Cord, just trying to make that process easier. We also worked on the way that XOS is containerized in Docker, so different elements of XOS are now running in separate Docker containers, and we're using the Docker Compose tool to configure XOS for particular scenarios and then manage the containers.
Okay, cool. Thanks.
Yep. Okay, for the XOS GUI, we have worked on setting up some tests that check the REST API functionality. We start from the basic model we need, and they are now running, but not under a continuous integration. And we should, in the future, start to think about that. We fixed some UI bugs that were around, and we defined a topology view for the service chaining, and we will show a demo of the proof of concept later.
Cool. Thanks. Okay, Acord.
So in this sprint, we have worked on a few enhancements on XOS to support the updation operations on the Ceilometer tenants, so that when something changes for a tenant, for example, the authorized POSIX list or resource list, that will be updated to the backend container so that the meters related to that project or resources will be reported. So that is one of the story, and the second one is to support the CPE or the subscriber gateway measurements in the bare metal containers. We added the support for it. And the big ticket item that we took up in this sprint is creating this ONOS notifier framework, and that can be extended to extract the measurements from the VOLP service or the VBNG service in the ONOS. Also, we enhanced the XOS ONOS synchronizer to deploy this application in all the ONOS instances in the card. Originally, we thought of it's a 1 week activity, but it ended up as being a full 2 week activity. That's why we couldn't finish some of the planned activities in this sprint. So the SFlow sample collection as a service, we have done few discussions, and we know the what to be done for this particular activity. But I will formulate a document and then take up this in the next sprint. The last one is the Raghu from Ericsson is working on it, and currently he's blocked because of some limitations from the Ceilometer software, and we are waiting for the inputs from the community on how we should address that issue.
Okay. All right. Cool. Thank you. All right. So we wanted to have a demo of traffic flowing from the OLT into the fabric into a VFG, but unfortunately we've been obviously rewiring stuff all the time as we're testing new stuff, and so we haven't been able to. Luckily, when we did this, Charles took a screenshot, so we have proof. so, so from this diagram, we have the OLT in blue down here, bottom right in the diagram, connected through this PK8 switch. And the only reason why we have PK8 switch is to use a media converter, is to treats it as a media converter from a 10 gig long range SFP to basically gigabit Ethernet. Well, actually 10 gigabit Ethernet here in this case. And from here we have a breakout cable coming from one leaf, and we break out the leaf into the PK8, onto which the breakout works as when you connect the breakout, you get new ports, and port 65 was connected to the PK8. And then there is a VLAN cross connect between port 9, well, port 65 really, and port 5. And then we were listening in a compute node for traffic that we sent. So we just sent traffic. We had on the OLT. We just had an ONU connected, and the ONU was connected straight into the server, and we just shoved packets into the interface connected to the ONU, which forwarded traffic through the OLT, giving it two VLANs, here, and as you can see, it's an ARP request, the packet. So it's really the first packet going through, and it's double tagged, and the packet gets double tagged at the OLT, gets media converted at the PK8 into the breakout cable, into the leaf where it's cross connected, into the VSG where we got this capture. Is there anything else you want to add?
No, I think you covered it.
Yeah. Okay. So basically that works, and if all of you guys are paying attention, this means that like starting next sprint, we're gonna start building this for real, kind of, more than less, and that means that like we're gonna have to like try and build this correctly. So that means I'm gonna come in and annoy people responsible for different parts of the infrastructure, so that we get things up and running. The challenge here is getting things up and running while allowing people to continue testing stuff. It's gonna be a tricky and difficult process, but we need to start building something. Okay?
That's cool.
Yeah, it's pretty cool.
So that VSG is a VCP container? Or?
Yeah, well, in this case, the VSG was just like a process. There was nothing there really. It's just that we got the packets in, and the packets had the right tags on them that we asked for and we wanted. So that means that like it's just the right packet that we got. Now the VSG here would strip off the S tag and forward the C tag into the VSG. The VSG would pop off the C tag and then process it. But we know that Linux knows how to pop off the tag.
But who pop up the S tag, you said?
OVS.
OVS on the computer.
Yeah.
And the cross connect and our fabric controller put some special rules, or it's like normal?
It's open source.
It's open flow rules.
No, but do we have some special logic in our fabric controller that this
Yes.
is a cross connect and?
Yes, we do. Because the second learning application, which controls the rest of the fabric, is based on untagged packets.
Yeah. So, but I mean, yes, it's special handling in the fabric, but it's all proactive. If that's what you're asking. It's all like we will tell
Which ports are connected?
Well, yeah, and we will tell the fabric like, hey. Well, in this case, in the first initial phases, it's all very easy because all the VSGs are dangling off the same port in the fabric.
Mm-hmm.
So whatever cross connect you have, you know where the target port is. Right? So that's a little bit like it's still some configuration has to be applied. But whenever we have a new customer, a new subscriber, we just tell the fabric, hey, these two VLAN tags, forward them to the VSG basically.
And if your VSG is on different nodes, compute nodes?
Well, right now we don't support that. We don't support that. We need pseudo wires to take a packet from the OLT rack, essentially, the OLT port, through the fabric down to another compute node. So right now we don't have that support. Okay. Matteo, you
Okay.
have a demo?
Yeah, I'm sharing the screen.
Okay, let's stop sharing.
Okay, it's the demo. It is really in a proof of concept state, early stage of development. So try to imagine that what I'm showing will be fitted in one of these tabs here. But basically, for now, we are showing how the services are linked together, and clicking on a service, we get details about the slice that compose that service, and we can inspect all the instances in that slices. What we want to do here is to draw a map of how the slices are connected to networks, and if the instance in a slice are connected to some other service for some other reason.
Do you want to overlay this on top of the fabric? No.
This is purely the sources coming from the XOS data.
Sure. But he's saying you want to overlay this on top of the network diagram.
No, he's saying within a slice what are all the instances, and he will show a connectivity between those instances and what is the subnet assigned to the.
Oh, okay.
You might want to change the BNG name to what we call it now.
B router.
Although, is it the same thing?
Yeah, it is.
It's the same thing.
Oh, this is for us, yes.
This is the service graph in principle,
Yes.
right? Yeah. So it should be called vRouter, I guess.
Yeah, we need to go through the XOS configurations and do some renaming because BNG is still called BNG. And Matteo's generating this from the current configuration.
What's the difference between service vault and service ONOS vault?
I think you should ask Scott. I'm just collecting the data and showing
I think
in a fancy way.
ONOS VLT is the ONOS instance that is hosting the VLT application. And service VLT is our XOS service that is tenant of this ONOS VLT application.
Okay.
Did you understand that?
They're on different.
Same thing,
they're on different-
even service VBNG is depending on the ONOS VBNG. Not just.
Oh, so wait. I think service vault. I think okay. Service ONOS vault is the VLT app on
ONOS, yes.
Service vault is the PMC VLT service or agent that we're using to talk to the device that XOS spawns as well.
So I would have thought that a service graph should only talk about the data plane traffic, right? What services the data plane traffic is going through. So in that sense, does it make sense to talk about applications on top of ONOS that are helping that data plane traffic go through the data plane?
Yeah, I think you're right. I think the service ONOS vault is really not something that like XOS should really. I mean, the XOS should not really be caring about this.
You know what I'm saying, right? If somebody wants to look at what the service chain or the service composition is for a certain data plane traffic coming from a subscriber, what you really want to see is what services that data plane traffic. You don't really necessarily want to see what control plane applications are helping that data plane traffic go through service X, Y, Z. What you really want to see is, oh, it's going to my VSG, then it's going to my service CDN, and then it's going out to my service internet.
Yeah, but
Or some other traffic is going directly from the VSG out to the internet.
Yeah, but hold on, because the thing is there's it's like these control applications can sometimes be services, right? If you think of like a very simple firewall, right, or a very simple firewall.
But you're not sending all data plane traffic through an
No.
application on ONOS to do firewalling.
No, but what you're doing is you're using that application to install rules that implement that function, right? You see what I'm saying? In some cases, the control app is the service.
Is this screen meant to show the data plane connectivity, or is this meant to show the components of a slice?
Today it is just the XOS service dependency. It is not depicting the data plane service chaining picture in this graph.
Okay.
What are all the XOS services and how they are connected.
Okay. Then what does each line mean the same thing? Does each line mean this is a tenant of this, or that this is a VLAN connect? What does each line mean?
What you said previous is correct. This is the tenant of the provider service. Suppose.
Okay. And does
service
that
VBN.
tenancy is directed, right? So how would you know that one is a tenant of the other in this?
Okay, that he has to put an arrow mark or something. So the service VCPE is a tenant of the service VBNG. It is in that direction.
Yeah. Well, I think it's sufficiently confusing that you might need to put in some more thought.
That's why I show everybody.
Yeah.
I think there's also a bit of a. We need to agree on some terminology and what the definition of that terminology is, and where functions, how do you represent services? Because I think that I don't know. I feel like there like a lot of confusion stems from, depending on the service, the notion of tenancy changes, which becomes very, very confusing because how do you represent that after? Anyway, let's carry on. Okay, so this kind of gets us to the end, and so on Monday we'll have our 6th sprint at 10 a.m. And it'll be also a 3-week sprint. So with that, thanks everyone, and we'll see you on Monday.
Guys.